Yesterday we talked about circumference of the circle and how to find the length of an arc and what the measure of an arc is. Okay. Today we're going to talk about the area of a circle and how to find the area of a sector. Okay. A sector is very similar to what the arc was. It's just the space inside the circle bounded by the radii and the arc. Okay? And we'll talk about that a little more here. First of all, let's remember what the area formula for a circle is. Pi r squared. Make sure you're using the radius. R stands for radius, not for the diameter. So if they give you diameter, be careful that you convert it to the radius. All right. So in this circle here, what's the radius?
6.
The radius is 6, right? The diameter is 12. Okay, and the radius is the distance from the center to some point on the circle. And so the radius here is 6. And so the area of this circle is pi times 6 squared. How would I leave it if they said leave it in terms of pi? 36 pi, yes. I would square the 6, but if they say leave in terms of pi, they mean leave pi in the answer. Okay? So if they say leave in terms of pi, they mean leave pi in the answer. Since it's centimeters and it's area, my unit would be square centimeters. Okay? If you leave units off on your quizzes, I take points off. So make sure you get in the habit of putting the units down. Alright? If there's no unit there, then just put U for units and U squared for unit squared. Okay? Any questions on this example? Okay, area of a sector. Here's the formula for area of a sector. There's really no great symbol for measure of an arc unless you know what that arc is. And so that up there just means measure of an arc. Okay? We don't know what that arc is until we're looking at a picture. But right now, so general formula would just say measure of an arc divided by 360 times pi r squared. Well, pi r squared is what? Area of the circle. So in other words, we're taking what fraction of the circle are we talking about times the area of the whole circle. Okay? Get caught up. So looking at this example, what's the radius of this circle? And what's the measure of the central angle? 110. So the measure of this arc here is 110, right? So this sector bounded by these two radii and this arc creates this piece of pi right here. Okay? So if I want to find the area of that sector, then I'm going to take the measure of the arc, in this case measure of arc AB, and it's 110 degrees, divided by 360. Anybody explain what that does for me? 110 over 360. What does that give me? I don't necessarily mean what number does it give me, but what does it represent?
How much area out of the whole circle?
Yeah. What fraction of the whole circle are we talking about? How much area of the whole circle do we want? We don't want the area of the whole circle, do we? We just want the area of that section right there, which is 110 degrees of the whole 360. Okay? So the fraction I'm looking at is, if I reduce is 11 out of 36 times the area of the whole thing, which is pi times 6 squared. What's 6 squared?
36.
So I get 11 pi times 36 divided by 36. What happens to my 36s? They cancel. I'm left with 11 pi inches squared, or square inches. And if they say round to the nearest tenth, then I'm just going to plug that in my calculator. If they say round, then I'm never going to waste much time reducing like I did here. Not that that took much effort, dividing by 10, since they both ended in zeros. Pretty simple, right? But I wouldn't even bother doing that if I'm going to plug the whole thing in my calculator anyway. Okay? So just pay attention to what the directions ask for. If they say leave it in terms of pi, then you have to reduce as much as possible. If they say round to the nearest tenth, then there's no point in reducing at all. Okay? Any example or any questions on this example? All right, moving on then. A segment of a circle. I'll pause this while you copy that down. All right, a segment of a circle. A little strange. Probably the first time you've ever seen this concept of a segment of a circle. So a segment is a part of the circle bounded by an arc and the segment joining its endpoints. Okay? So when I say a segment joining its endpoints, I mean this is arc AB. Oops. Try to write that down correctly. This is arc AB, and so the endpoints of arc AB are A and B, and if I join them with this segment, then this segment of the circle is considered to be this area right here that's in blue or aqua or whatever that is. Okay? So it's bounded by an arc and a segment connecting the endpoints of that arc. Alright? Now, finding the area of a sector is pretty straightforward. This one's just a little bit trickier. So when we do an example on this, you're going to have to understand the concept is simple. I'm going to find the area of the whole sector, and I'm going to subtract from it the area of this triangle. Okay, the difficult part is sometimes finding the area of that triangle. Okay, finding the base and the length of the base, the length of the height based on this radius sometimes is difficult. So we'll have to look at each one a little differently. Okay? So here's the concept. This is the area of a sector. And if I subtract from it the area of this triangle, I'm going to get the area of the segment. So here's an example. We want to find the area of the shaded segment. Okay? Well, of course, in my example, I gave you a nice simple triangle to find. Now, a difficult one. We might have to, on some of them, use the concepts we've learned in the last 3 or 4 lessons. But in this one, what kind of a triangle is that?
Right.
It's a right triangle. And how much of a circle is this segment? Let me try it again. How much of the circle is this sector? How much of the circle is that? A fourth. It's 90 out of 360. So we're going to find the area of the sector minus the area of the triangle gives me the area of the segment. Okay? So the area of the sector, 90 out of 360 times pi times r squared, right? Area of a sector. The measure of the arc divided by 360 times the area of the whole circle, which is pi r squared. And someone already said that this reduces to 1/4. Is that 324? Yeah. Okay? And a quarter of 324 is something like 81. Okay? Minus the area of the triangle. How do I find the area of a triangle? 1/2 the base times the height, right? Well, if I look at this, rotate this just a little bit. And so I look at that right there. What's the base length of that triangle? And what's the height of that triangle? Say again? I'm sorry, I can't hear you. 18 and 18. And so they're both radii, but because they're a 90-degree angle, they're perpendicular to each other. That means that one is the base and one is the height. And so area of a triangle is 1/2 the base times the height. So it's going to be 1/2 of 18 times 18, which is 18 squared, right? Half of 18 squared is 162. Oops, sorry. Didn't mean to write equals. Now, if they say leave this in terms of pi, then this is my answer. If they say leave it in terms of pi, that's my answer right there. If they say round to the nearest tenth, then I'm going to go ahead and say, what is 81 times pi minus 162? Plus. Okay? If they say leave it in simplest radical form, well, in this one we don't have any radicals, but in the next one you might. But the point is, these are not like terms, so I cannot subtract them the way they are right now. Okay? And if I had a radical in there, I wouldn't be able to subtract the radical from a pi either. So you'll have to look at what you have and then answer appropriately to the question. All right? Any questions on this example? Again, this one was pretty straightforward because the triangle was a simple one to find. Okay, I left myself lots of workspace, didn't I? All right, today, let me pause while we find the assignment. Today's assignment then is 773 to 36. That's only 12 problems, and then the checkpoint quiz number 2. Okay? Expect a quiz tomorrow. I normally like to have more than a day in between, but tomorrow we're going to have a quiz over lessons 4, 5, and 6, and 7. Sorry. 4, 5, 6, and 7. Okay?